If you're looking for someone with a normal human sleep schedule, I'm probably not your guy. Nighttime is when I do all of my best working, a lot of my best playing. Being awake at 8 a.m., not my thing. And while part of me wishes I didn't have to sleep at all, I definitely do enjoy it. The need to sleep is one of the strongest biological urges we have, one of the few that we really can't control. And the fact is, you can die faster from sleep deprivation than food deprivation. So it is time to investigate the science behind this thing that we do for a third of our lives. Just try and stay awake for it. Even though the average person will spend 25 years of their life asleep, there's no scientific consensus as to why exactly we do it. One thing we know for sure, our brains definitely think that sleep is important. Deep in your hypothalamus, the tiny nut-sized region at the base of your brain, you have a little cluster of cells that acts like a timer called the suprachiasmatic nucleus. When you're exposed to light, this little cluster busily releases awake hormones like cortisol and suppresses the release of sleepy hormones like melatonin. When it's dark, it does the opposite. A second trigger for sleep is believed to be the buildup of the compound adenosine in the brain. Adenosine is a byproduct of your neurons and other cells when they burn up adenosine triphosphate, the main molecule that our bodies use to store energy. Research suggests that when a bunch of leftover adenosine accumulates in your brain, you get sleepy. We talked about adenosine before when we went into the science of caffeine, because caffeine works by bonding to the same receptors as adenosine, tricking the body into thinking it's not tired. But when you do sleep, those adenosine levels drop as it's gradually reabsorbed by your neurons. This is partly what makes you feel rested when you wake up. So, we sleep when our brains tell us to sleep, but that doesn't answer the larger question: why are we wired to sleep? It seems like a kind of terribly inconvenient thing to have to do, also super dangerous if you're surrounded by jaguars or something. There are lots of theories out there, and it's unlikely that any of them alone is the single answer. Instead, they may all contribute to this weird urge that we have to lapse out of consciousness. For starters, all mammals and birds sleep, and other critters like reptiles, insects, and fish exhibit some kind of sleep-like behavior. That even includes the millimeter-long nematode worm, which experiences stress when denied rest. Some scientists suggest that inactivity at night is an evolutionary adaptation that boosts an animal's survival rate by keeping it out of danger when it would be most vulnerable. Basically, sleep could be a way to keep still so you attract less attention. And yet, lions sleep a whopping 15 hours a day, while Mr. Giraffe, arguably a tasty meal for said lion, gets less than 2 hours a day. So another theory is that sleeping might be a way to conserve energy. Much of life, at least in the wild, is about procuring calories to keep going, so going dormant for about a third of your day could be a smart move. Humans use about 10% less energy when they're sleeping, as our breathing and heart rate and body temperature all take a dip. But the broadest support out there for sleep theories is that it provides restoration. Sleep, after all, is when you grow muscle tissue, your cells synthesize proteins, your tissues repair themselves, and growth hormones are released. But surely we could take care of all that without having to be unconscious, right? Like, why can't our cells fix themselves while we're sitting on the couch watching Real Housewives of Milwaukee? Because our brains need sleep as much as our bodies do. Emerging research suggests that sleep allows the brain to rejuvenate and, maybe more importantly, reorganize. This theory is known as brain plasticity. We all do and see a lot of different stuff every day, and we'd probably like to remember most, but not necessarily all of it when we wake up. Brain plasticity theorizes that sleep is when our brains replay and store the events of the day, providing 8 hours or so for the processing and consolidating of new memories. This theory has been supported by tests on human subjects. In one experiment, a set of volunteers memorized sequences of patterns in the morning, while a second set memorized them in the evening. The morning group had their memories tested 12 hours later without sleeping, and the evening group was tested 12 hours later too, but after they'd slept. And the evening group proved better at recalling the patterns. It may actually be good advice to take a nap while you're stuck on your problems, or sleep on a big decision that you have to make. Your brain may need that time to process everything you've observed. But if sleep helps reinforce memories, what about the stuff we like to forget? Like, I don't have any reason to remember the color of the car that cut me off this morning, or the words to the radio commercial where the guy's singing about furniture. Luckily, sleep can help clear out all that excess junk from from our brains. When you form memories during the day, your brain strengthens the synapses or junctions between neurons. Learning new things often causes neurons to create entirely new synapses. By tracking the bursts of electrical activity that happen 1,000 times each night among your billions of neurons, scientists have discovered that during sleep, both high-frequency and low-frequency bursts increase, but moderate-frequency bursts decrease. In other words, your brain is choosing to either rev up or calm down the firing between each of those synapses you made while you were awake, ultimately strengthening or weakening each connection. So, though it's a little sad when you think about it, when you wake up, the insignificant details about the previous day are probably lost forever. But keep in mind that without this daily cleaning, your brain would face a major energy shortage and space crunch. In a way, this function of sleep is kind of like defragging a hard drive. Problem is, people, Americans in particular, don't get enough sleep. In a survey conducted by the National Sleep Foundation, Americans on average get over an hour less than the recommended 8 hours a night, and teenagers need even more. In addition, nearly 20% of Americans report problems sleeping, more than 200,000 car accidents each year caused by sleepy drivers, killing more people than drunk driving. It doesn't take long for the brain and body to feel the effect of sleep deprivation, and the problems compound with time. Just go one night without sleep, and your brain quickly starts trying to scramble, beginning with the amygdala, the part of the brain that tells the body to be prepared for danger. Short-term sleep deprivation throws the amygdala into overdrive, which in turn shuts down the prefrontal cortex. That's the part of the brain that controls logical reasoning, among other things. So a single all-nighter can put you in a state that one researcher has called emotional jello. Because when it bypasses the prefrontal cortex, the sleep-deprived brain connects instead to another part that, evolutionarily speaking, is one of the oldest and most primitive regions. It's called the locus ceruleus, or the blue spot of your brain, because for some reason the tissue is actually blue. Its job is to make you respond instinctively to stress and panic. Only it can interpret pretty much anything as a threat. A swerving car, a terse email, an offhand remark by a boyfriend, leaving you anxious and suspicious of everyone and everything. And the longer you go without sleep, the worse things get. Memory and speech control are the next to suffer, but after several days, things really start to get weird. General paranoia can give way to increasingly vivid hallucinations. Some theorize that this is your brain actually forcing you into a waking sleep. But the question is, can a lack of sleep actually kill you? And the answer is almost definitely yes. Sleep is closely tied to immune health. Studies have shown a 50% decrease in antibodies in test subjects who were only moderately sleep deprived for 1 week, exposing them to a host of illnesses. And in a famous sleep study from the 1980s conducted by sleep researcher Alan Rechtschaffen, a group of rats deprived of sleep all died within 2 weeks. The cause, as far as Rechtschaffen could tell, was simply exhaustion. Nothing, physically, was wrong with them. A follow-up experiment conducted in 2002 similarly failed to find an unambiguous cause of death. So probably you want to know, how long can you possibly go without sleep? Well, the longest documented case of a person voluntarily staying awake is 264 hours, or roughly 11 days. It happened in 1965 when 17-year-old Randy Gardner set the record as part of his science fair project. Gardner emerged relatively unscathed physically, most likely a result of his age, but he was described as being cognitively dysfunctional at the end. While awake, he experienced blurred vision and involuntary eye movements, and his hallucinations included seeing fog around streetlights, feeling a band of an imaginary hat, and believing that he was a running back for the San Diego Chargers. The lesson here, I think, is don't try to beat Randy Gardner's record at your next school science fair. There's really nothing good that can come of it. Thanks for watching this episode of SciShow. If you have any questions or comments for us, we're on Facebook and Twitter and down in the comments below. And if you want to keep getting smarter with us here at SciShow, you can go to youtube.com/SciShow and subscribe.